To Barbika and Bharti with Avilas Sarkar. The next problem that will come is number 28 on fluid statistics. So 28 problem says a tank contains water on top of mercury. A tank contains water on top of mercury as shown in figure. A cubical block of side 10 centimeter is in equilibrium. Inside the tank. The depth of the block inside mercury, the depth of the block inside mercury is how much? Given relative density of the material of block is equal to 8.56 and relative density of mercury is 13.6. Okay, so let me draw the figure how it is look like. There is a 2-layer fluid and the block is somewhere dipped partially into the water. Water definitely will be on the top because mercury is heavier than water. So this part here mercury and this is block, and block anyhow I separate it like that. So this is the block that is submerged partially in water. This part is your water, this part is a mercury, and this is the clear cut border of this. This you can take as water. Okay. And this is the block. Okay, so now let me read the question again so that you can go ahead. A tank contains water on the top of the mercury and shown in the figure. A cubical block of side 10 centimeter is in equilibrium. It is a block of 10 centimeter that is having a cube, not cuboid. It is cube. Inside the tank, the depth of the block inside the mercury is how much? So if I assume that this is the total height of the block, let's say if it is h is given as the 10. Now part of it, maybe I have taken it as capital H, is h inside the mercury. That is the case. Now the remaining will be the 10 minus h. Okay, so now as it is in equilibrium, so that means the block, how much it is fluid as a whole, it dispersing will be the equal to the buoyancy. So the weight of the block will be the upthrust due to the water plus upthrust due to the mercury. This could be the case when in equilibrium. Actually, if it is one liquid, then what we are doing, the weight downward is being balanced by the upthrust. Now, as because there is two liquid, that upthrust caused by the water, which will act upward, and upthrust due to the mercury will upward. This all together will balance the weight which is acting downward. There is no other force which is causing the fluid, causing the block to be in suspension and equilibrium inside the fluid. Okay. Now we have assumed this is the h of the depth inside which the block is submerged in the mercury. So what is the weight of the block, volume of the block, density of the block into G, that is equal to upthrust means same V rho G. V is in this case water, volume of the water. So volume of the water, the block is uniform cross section all direction. So if I assume that block is somewhat like that, okay, and partially it is dipped, so only the part which is dipped here, the cross section for both the liquid it will be same. So what is the cross section? Cross section into the height of the water column, that will be the volume of this. So I will write first the volume of water, density of the water into G, and for volume of mercury, density of mercury into G. This will be the simple equation. Now this G is not contributing any difference, so G is being cancelled out. What is volume of block is of cuboid of side 10 centimeter. So this will be the 10 cube into the block density we don't know. So what we will do, before putting it, what we will do, as because the relative density is given, so I will divide everything with rho of water, because RD, the relative density, is always calculated with respect to water. So the any material density is, if it is so the block density by the block by the rho of the water, rho of the block and rho of the block, if I divide, that is the RD. So my intention to convert it in same way. So this will be the only volume, and this V of mercury, rho of mercury by rho of. So this will be the case. Now this is given volume of the block. Volume of the block is nothing but, as we know, the volume of cube is 10 into 10 into 10. Okay, this 10, 10 and 10. 3 dimensions, so 10 cube. The relative, this is nothing but the relative density. The relative density of the block is given 8.56. I will put it directly here. Is equal to volume of water. Volume of water is the cross section of the block on the top. So that is nothing but 10 square, because all dimensions are same, is this cube. 10 square, sorry, into the depth. As I have taken h, small h is the depth inside mercury. So this will be 10 minus h plus volume of mercury is this also 10 square into h this time. What will take h in the mercury? So the cross section, if I divide from here also, the cross section will be same into h. So that is there, and the relative density of the mercury is given 13.6. That will be multiplied there. Understood? Now 10, 10, I will reduce it by 10. So this will be nothing but 85.6 here is equal to 10 minus h plus 13.6 h. Okay. Now write this part. So what will remain? 12.6 h, 12.6 h, and 10 will go that side. It will give 75.6. So H is equal to 75.6 divided by 12.6. So that will be around how much? I think 6 will be the best. 6 6 are 36, 6 to the 12, 15, 1, 6 1 plus 1 7. Yes. So this is equal to, so H, the height of the block that will be there inside the mercury is 6 centimeter will be the answer. Okay. Now we'll move on to the problem number 29. Problem number 29. A metallic sphere floats, metallic sphere floats in immiscible mixture of water, density 10 to the power cube kg per meter cube and a liquid density 8 into 10 to the power cube kg per meter cube such that its 2/3 part is in water, and 1/3 part in the liquid. Okay. Find the density of the metal. Okay. Find the density of the metal. So if I draw the figure, a metallic sphere floats in an immersible mixture. There are two different mixture. One is water and this is another liquid of density. So this is much heavier than water. So that liquid will somewhere lie there at bottom side, and the water will be there on the top of that liquid. Okay. Now a sphere is merged in the such that 2/3 part is in water. So if I assume this is the sphere, so just to make understand, this is the sphere. So the 2/3 part, if I say as per the height, 2/3 part is, but it must be as per the volume. 2/3 part of the volume is inside and 1/3 of the volume inside the other liquid. This is liquid, this is water, other liquid. I mean to say water also a liquid, so this is other liquid. So this is the case. So now this similarly will be treated as the previous problem. Okay. And the volume of sphere, you know, 4 by 3 pi r cube, where r is radius. It may be required, I don't know. So, but this is the formula for the volume of the liquid. So, weight of the sphere is equal to upthrust due to water plus upthrust due to unknown liquid. So, this again V of the solid volume into the rho of the solid. I'm not writing G, because G anyhow it is eliminating from the equation, so I'm not writing. So what is the remaining part? I'm writing the volume and thus the density, volume of water dispersed, the density of the water plus volume of the unknown liquid into the density of the unknown liquid. That will remain. Okay. Now density of the liquid water is given. The density of the solid we don't know. So my requirement of the density of the solid is required volume by volume S W plus volume of unknown liquid by the volume of the solid and rho of unknown liquid. Now what is this part? Volume of water divided by volume of solid. That is said to be 2/3 part, isn't it? So I will write directly 2/3 for water into rho is equal to 10 to the power cube plus what is this? Volume of unknown liquid by volume of solid is 1/3. So is equal to 8 into 10 to the power cube. This will be the case. Understand this point. Volume of the liquid dispersed, that means this will disperse that much that which is inside the liquid. So this fraction will be the 2/3 of the 2/3, because that is said the such that its 2/3 part is in water. So if it is in water 2/3 part, so that 2/3 part of water it will disperse. So definitely, and for the case of liquid this is the, and then 1/3 into 10 to the power 3 will be taken. This and 1/3 is common for both. So what is remaining? 2 here plus there is 8 again. So this again will add up 10. So this is 1/3 into 10 to the power 4 of what? Kg per meter cube will be the density of the metal. Okay. So this will be your answer. Now going to number 30. Two non-mixing liquid of densities rho and n rho of densities rho and n rho are put in a container, The height of each liquid is small h. The height. Oh, here one more thing. N is greater than 1 it is said, are put in a cylinder or in a container. The height of the liquid, each liquid is h. A solid cylinder a solid cylinder of length L and density D is put in this container. The cylinder floats with its axis vertical and length PL, where P is less than 1 in denser liquid find D. So let me read it out again. The two non-mixing liquid of density rho and n rho, where n is greater than 1, are put in a container. So you can understand the later density is higher because n, which is multiple of rho, is more than 1. So that n rho, whatever the liquid is there, will be at bottom. This is the n rho where n is greater than 1. So this liquid is heavier, so this will be there in the bottom, and the other liquid which are having the density rho will be at the top. So that is understood. The height of each liquid is h. So this is also given. The height of each liquid is h. Find a solid cylinder of length L and density D is put in the container. So a solid cylinder, maybe this kind of cylinder of length L total, and density D, this density is D, means rho is equal to D, is put in the container. The cylinder floats with its axis vertical. So this is the axis, okay, this is the axis and it is vertical. So what I have drawn is right. This cylinder will float in this condition, means axis is vertical and it will be towards length, it will float with an axis vertical and length PL. P this time, so I can put small p, which is a fraction of the total L, where p is less than 1 in the denser liquid. So this part of length is small p into L. Okay, I treat it as small p. Okay, so this is fine. So now again the volume of the cylinder, if I take, is equal to pi r square into L. This is the volume if I take the whole length. Okay, now this part is inside the denser liquid. So again the weight of the cylinder is equal to the upthrust for the if I name it liquid 1, this is liquid 2. So this is L1 and upthrust due to the liquid 2. Now volume of the cylinder into rho of cylinder, volume of the liquid 1 into the rho of the liquid 1 plus volume of the liquid 2 and rho of the liquid 2. This is same, is going in the same way. Now the two non-mixing liquid put in a cylinder. The height of the liquid is the solid cylinder of length n and density is put in a container, and the cylinder floats with the axis vertical and the length PL in denser liquid. This is solid cylinder. No, there is no ambiguity. This is solid cylinder. That means uh, the fine. This is H. Both the height is H. Now, okay, fine. So, what is the volume of the cylinder? Volume of the cylinder is as it is pi r square into L total length, and rho of C density of the liquid one. That means the density of the of the cylinder is given as D. This is volume of the liquid one, which is volume of the solid that is in liquid one, that means this one. So this is PL. So this is the other part will be 1 minus P into L, because that will be the L minus small PL. So if I take L common, so this will be 1 minus P. Okay, so 1 minus PL. So the volume is equal to L into 1 minus for liquid 1, that is on the top, into this is the length into the area is same pi r square into rho of the liquid one, that is the lighter one, this is rho, simply rho, and that of the second one would be the P into L, length into pi r square into n into rho. This is the density. Fine. So now, so here you can see that this part pi r square is same everywhere. So for cylinder, this part is not again contributing. So when we will discuss about the cylinder vertically, axis vertically up, we need not to write it here different. So what you can write directly, the length into the density is equal to the length here also into the density is rho, and here also length into the density n into rho. Okay, now what is the D here? L if I divide, so L also will not participate here. L is a multiple of everything here. So this is 1 minus P into rho plus PL. This is P into N into rho. Okay, so the all total, if I take, this is rho minus P into rho plus NP into rho. So if I take rho common, 1 minus P plus NP. So this will be your answer. Now one thing you just see, the depth of the liquid, it is not being used. That is a additional data given just to confuse. Now this could be useful if the position of the cylinder is not fully submerged to the total column of the liquid, that is some part is outside, then this could be a part which there it can be used. But in this case, due to this height difference, this is the same height and all that, that is not coming in the calculation. Okay. Fine. Okay. So here I will end my this session. In the next session I will move on to the problem number 31 and onwards. So thank you for now.